Welcome to Modern Approach. In today's video, we're going to cover the top 5 MongoDB interview questions and answers that will give you the edge in your next interview. Stick around till the end to find out the most important question you'll likely be asked. Let's get started with question number 5. Question number 5, what is MongoDB, and how does it differ from traditional relational databases? Why, they ask. Interviewers ask this question to gauge your basic understanding of MongoDB as a NoSQL database and your ability to compare it to more common relational databases like MySQL or PostgreSQL. Here's how you should answer this. MongoDB is a NoSQL database that stores data in a flexible, JSON-like format called BSON. Unlike traditional relational databases, which store data in tables and rows, MongoDB uses collections and documents, making it more scalable and better suited for handling large volumes of unstructured data. The lack of a fixed schema gives it flexibility, allowing for rapid changes in data structure as application requirements evolve. Pro tip: highlight how MongoDB's flexibility in handling unstructured data and its horizontal scalability make it a top choice for modern applications with dynamic requirements like social media platforms or big data projects. Question number 4, how does MongoDB achieve scalability, and what are sharding and replication? Why, they ask. Scalability is a critical factor in modern applications, especially when handling large data sets. By asking this question, the interviewer wants to test your understanding of MongoDB's architecture and how it handles both vertical and horizontal scaling. Here's how you should answer this. MongoDB achieves scalability primarily through 2 methods: sharding and replication. Sharding is the process of distributing data across multiple machines, or nodes, allowing MongoDB to handle large datasets and high throughput. Replication, on the other hand, ensures data redundancy and availability by creating multiple copies of data across different servers. This replication process is managed through replica sets, where one node is the primary and the others act as secondaries, providing failover and backup. Pro tip: when answering, emphasize MongoDB's ability to automatically manage large-scale systems through horizontal scaling and its built-in fault tolerance through replication. Mention specific use cases where these features are beneficial, such as in global applications that require high availability. Question number 3, explain the difference between embedded documents and references in MongoDB, and when would you use each? Why, they ask. This question aims to assess your knowledge of MongoDB's document model and how you approach data modeling. It's essential to understand when to embed data directly versus linking related documents through references. Here's how you should answer this. In MongoDB, you can either embed documents within other documents or reference them. Embedded documents are stored directly within a parent document, providing faster read operations since everything is in a single place. This is ideal when the embedded data is closely related and will be accessed frequently alongside the parent document, such as in the case of a blog post with comments. On the other hand, references involve storing relationships between documents by linking them via unique identifiers, which is useful when related data needs to be accessed separately, or when embedding would result in excessively large documents. For instance, in a system with many-to-many relationships, like users and orders, referencing provides more flexibility. Pro tip: an effective way to stand out is to explain the trade-offs between embedding and referencing in terms of performance and data integrity. For example, while embedding can speed up reads, referencing might be better for maintaining data consistency, especially when the related documents are frequently updated independently. Question number 2, how do you ensure consistency in MongoDB transactions? Why, they ask. This question dives into how MongoDB manages asset atomicity, consistency, isolation, durability properties in multi-document transactions, a feature MongoDB added in later versions to compete with traditional relational databases. Here's how you should answer this. In MongoDB, transactions provide asset guarantees across multiple documents, similar to what you'd expect in a relational database. To ensure consistency, you need to use start session and start transaction to begin a transaction that spans multiple operations. If all operations succeed, the transaction can be committed with commit transaction, ensuring that all changes are applied atomically. If any operation fails, the transaction can be rolled back using abort transaction, maintaining data consistency. Pro tip: Emphasize that while MongoDB now supports multi-document ACID transactions, it's often best to design schemas that minimize the need for complex transactions, focusing on single document operations that are atomic by default. This approach can boost performance and reduce complexity. Finally, the number one question you're likely to encounter: what is an aggregation pipeline in MongoDB, and how does it differ from MapReduce? Why, they ask. Aggregation pipelines are one of MongoDB's most powerful features for data analysis and manipulation. Understanding how they work and when to use them versus the older MapReduce method is key to handling complex queries efficiently. Here's how you should answer this. The aggregation pipeline in MongoDB is a framework for transforming and analyzing data through a series of stages such as $match, $group, and $sort. Each stage processes the input and passes the result to the next stage. This pipeline approach is highly efficient for performing operations like filtering, sorting, and calculating aggregated values directly within the database. MapReduce, on the other hand, is an older method for data processing that involves two phases: the map phase, which processes and transforms each document, and the reduce phase, which combines the results. While MapReduce is more flexible, the aggregation pipeline is typically faster and more efficient for most common operations. Pro tip: make sure to mention that MongoDB's aggregation pipeline is preferred for most use cases due to its performance benefits. However, in cases where you need more flexibility, such as distributed data processing or when dealing with very large data sets, MapReduce might still be a viable option. That wraps up our top 5 MongoDB interview questions. We hope these answers will help you ace your next interview. Don't forget to like and subscribe to Modern Approach for more interview prep content.